Okay, I don't know if you still remember this circuit. Okay, this is our audio circuit. It is an mini small outline integrated circuit, LM4871. Okay, now there are some updates happened to this circuit. So we are going to erase, this is the signal in. Let's erase some issues here to be able to do the new configuration. We have added a variable resistor for the volume of 100 kilo ohms. Okay, like this. So, and here we have added a capacitor of 1 microfarad. Okay, SMD capacitor, coded 105, which is C4. Okay, so it goes like this. The signal goes in here like this, and it goes to the middle of the, after passing the C4 1 microfarad, and it is also coded as 105 code SMD. Okay, the ground is going the same from here till here, no change. This is the ground, the same, and the signal comes in, signal in. Okay, the same. All right, here we have the power supply. The power supply that we already have designed. It has two outputs, 3.7 volts outputs and 3.2. Okay, this is our power supply unit. Okay, C4 تساوي 1 microfarad. Okay, and here we have, this is the ground. Okay, and we have two output voltage, VCC1 and VCC2. Okay, and so we have two outputs, VCC1 and VCC2. This one is 3.724 volts, and it goes to the audio chip, and this one is 3.2 as maximum volts, and it goes to radio. So this one goes to radio circuit, to our radio chip. Okay, so those are the changes and updates. The variable resistor for a volume control, and that is 100 kilo ohms. Okay, this is a potentiometer. It is here 100 kilo, and we have the power supply that already contains a capacitor electrolytic for 70 microfarads. So no need to the previous electrolytic. Okay, so this one now is already deleted because it's already on the power supply unit. And go back to the video before to see how did we design this power unit out of a lithium ion. And it has two output voltages. And why two voltages? Because this voltage is to enhance the gain of the circuit, enhance the gain and increase the gain of the chip itself. Okay, this is the ground, as we said. It goes till the potentiometer. Okay, here. So I'm going to hold it to the screen so that you will be able to print it out. The band selector that's initially found in the radio that we already have installed, we have three positions. First off, this is the common, and there is a round around it, indicating that this is a common. Okay, now when you push to this position, the last position, those two will connect. Likewise on this side. At the middle, this will connect to here. And in our color coding, the the orange is the MW, the violet, this is for FM. Okay, and this light green here is for the shortwave. So the first position for FM, you see they are connected. The second position for MW, and the third position for shortwave. And we said about the slider also. Once you come to here, the slider will do the other part of the jobs. This is how the band selector configuration is set up. Okay, this is how the band selector is working. This is 67 kilos, RF1, RF2 170 kilos, RF3 83.5 kilos, and the last one here, RF4 33.3 kilos. Now those are a fixed resistors. You need a range of 100 kilo to divide it into 20 plus 20 plus 10 plus 20 plus 20 plus 10. This will make a 100 kilo ohm. So from the first 67 kilo you got the FM. So you should connect pin number 4 band selector to this way here. If you want to go to MW, you go and connect to MW. This one here, RF3, will make the first meter band. That is 49 meters. So you connect to here. Then you go to 41 meters. That is by connecting the additional 20 kilo. And another 20 kilo will give you meter 31 meter, 25 meter after 10 kilos, after additional 20, 22, additional 20, 19 meters, and the last one after the 10s, which is the 100. Now you will get the 16 meters. So now you have 7 positions plus the 2 position, you have 9 positions, and that is the 9 band radio. Okay, now this of course will go to pin number 2, and this is the ground. The problem is you need a band selector, and in our radio there is no way, it is too small. So what do you do is we come up with this idea, a slider potentiometer, that it should be going like this. It will be like this, and instead of any switch, no need for the switch, you set it up for 20 plus 20 plus 10 plus 20 plus 20 plus 10, and you will get the 7 position. The first 0 of it will constitute the first position is SW2, SW1, which is 49.m. That is because of this RF3. And you connect pin number 4 to this place, and you connect it like this. Okay, this is how actually we solve this problem. This is the pin out of the chip, and this is the color coding that I set up for the wiring. So we have the purple or magenta for tuning number 1, and we have the light blue for tuning number 2, dark blue for band selector, violet for FMRF input, light green is for EMRF input, yellow is for volume control, the gray is for crystal oscillator, the red is for voltage supply, the black is for the ground, and this dark yellow is for the audio output, this dark green is for reset. Okay, so pin number 1, let's start. From the pin number 1 through 16, we start from this dot, which is actually represented on the top of the chip. This is not used in our circuit. It is for the shortwave external LNE enabled. Go back to the previous videos to know what is it about, but we are not going to use it. We are not going to use pin number 5. This is not used. We will leave it float. And pin number 10 and 11 will be connected in our circuit to the ground because we will use an outside audio amplifier. So we start from pin number 2, which is go to tuning number 1, and number 3, the other pin is for tuning number 2. This number 4 is the band selector. We are going to make an input for RF for FM from pin number 6. Pin number 7 is the ground for the chip RF ground, which is going to be connected to the main ground of pin number 15, which will go finally to the ground of the PCB, right? And pin number 8 is the EMRF input. Pin number 9 is for reset. Pin number 10 and 11, this is for volume control. Pin number 12 and 13, this is for the outside crystal oscillator. This is the power supply, the VDD, and this is the mini ground, and this dark yellow is for the audio output coming from the circuit. So I'm going to hold this picture to the screen so that you can print it out if you want. Okay, my friends, I have designed this circuit for this chip to actually achieve maximum performance with also keeping the smallest size possible. And I have to say, it actually proves efficiency and proves maximum performance actually. I have tested it many times, and I am presenting it to you all, hoping that it is going to provide something enjoyable to all of you. And I have to say, it is actually more superior to the typical circuit. Actually, typical circuit is considered nothing compared to this professional circuit. So let's just start explaining about it, and if anything unclear, you can contact me using the comments. As you can see here, pin number 4, which is the band selectors, is on the common side from here, and you have 3 positions: the FM, as indicated before, and MW, and shortwave. And this VR1 is the slider variable potentiometer that is actually changing in between the meters from 49 meter to 16 meters as shown before. Okay, those two is the RF coil connected to the negative rail or the ground only when it is on the MW band, but once it is on the FM or shortwave, it is disconnected so that you can have a better receiving, okay, and no interference. I forgot to mention this inductor. It is L1 here. This is the an SMD inductor, but you can use any other inductor. Okay, here is the radio circuit. We have the resistors R1, R2, R3, R4, 5 resistors, SMD resistors, and we have also another SMD resistors, but we give them another name: RF1, RF2, RF3, and RF4. We have the slider resistor for the shortwave bands, we call it VR1, and we have the tuning resistor, and that is RT1. Okay, here are the values of the resistors. RT1, R tuning, is 100 kilo ohms. VR1, which is for this one for shortwave, okay, shortwave bands, it is also 100 kilos. We have R1 equals to 100 ohm, R2 equals to 10 ohm, R3 470 ohms, R4 120 120 kilos. And those are the codes written on the SMD resistors. Okay, RF is 10, R5 is 10 kilo ohms. Okay, then RF1 is 67 kilos, RF2 170 kilo, RF3 83.5 kilos, RF4 83.3 kilos. Okay, we have SMD capacitors. Okay, C1, C2, C3, C4, C5, C6. Okay, C7, C8, 9, 10. C7, C8, 9, 10, 11, 12, 13, 14, 15. Okay, and the values are like this. C1, C3 equals to 10 nanofarads. Okay, or 103 code who want to use a ceramic capacitor. C2 and C6 are equal to C11, they are 100 nano. C4 equals to C5, they are 10 nanofarads. C7 equals to C8 equals to C15, all of them are 25 picofarads. C9 and C12 are 3,300 nanofarads, which is coded as 332 for anyone who want to use the ceramic capacitor, normal ceramic capacitor. C10 equals to 4,500 nanofarads. C3 is the 333 picofarads. C14 is 470 nanofarads. Okay, we have Q1 transistor, NBN transistor. You can use S9018. This is the base, this is the collector, this is the emitter. And Q2 is a diode, Okay, diode going like this and diode going like this. Two diodes at the same time. You can use any other diodes. Okay, like here. This is an inductor, okay, which is L1. This is an RF coil for NW. This is a crystal oscillator, okay, and all of them are indicated here like this. This one is a Q1, S90ET and BN. Q2 is nothing but two diodes going to the point number 2. Of course, this is 1, this is 1, 2, 3, just like here, 1, 2, 3. So from 1 to 2 and from 3 to 2, those are two diodes. L1, it has about 0.01 millihenry. Okay, it is about 0.01 ohm as resistance. L2, which is the RF MW coil, 0.033 millihenry, and it's about 3 ohms. The crystal oscillator is equal to 32.8 kilohertz. Okay, so now I'm going to hold this diagram at the screen for anyone who wants to print and study it.
وديتيها الضمانية مخربطة. وديتها الضمانية قالوا بدي الصيانة تبي زين، رحت بلزي ركبت على حالها لقيتها. Bye-bye.